Pouring a glass of water looks harmless. It's clear, has no smell, and looks exactly like the water humans drank for thousands of years. But today, that perfect clarity disguises a lethal, invisible threat. Data from the NITI Aayog reveals a crisis on a massive scale. 70% of India's water is now contaminated. Historically, our water safety efforts focused on biological threats like bacteria and cholera, pathogens we can neutralize with heat, but those have been replaced by indestructible chemical contaminants that exist at a molecular level. We face a three-tiered chemical hierarchy. It begins with naturally occurring radioactive uranium, followed by industrial heavy metals, and finally synthetic forever chemicals that stay in the environment for centuries. These modern threats have rendered traditional purification useless. If you boil a pot of water laced with heavy metals, you don't remove the poison. You simply boil off the pure water and increase the concentration of the chemicals left behind. In the agricultural hubs of Punjab and Rajasthan, intensive farming is draining the water table faster than rainfall can replenish it. To keep their crops alive, farmers are forced to chase the receding water deeper into the earth. Bore wells reaching deep bedrock disturb the geology, allowing radioactive uranium to leach into irrigation and drinking water. The Central Ground Water Board chart shows the impact. In Punjab, 62.5% of samples exceed safe limits, marking it our most contaminated region. The problem is compounded by excessive fertilizer use. Toxic nitrate runoff from these chemicals percolates into these same depleted aquifers, leading to severe health issues like blue baby syndrome in rural communities. By over-extracting water for agricultural survival, we have inadvertently pulled the radioactive secrets of the Earth's crust directly into our food and water supply. Beyond the farms, India's industrial hubs create a different kind of chemical burden. Tanneries in Kanpur and textile mills in Tiruppur use billions of liters of water to process leather and fabrics, generating massive quantities of toxic waste. While laws require this waste to be treated, many units bypass common effluent treatment plants to save on costs. Others use technology that simply isn't designed to handle complex organic solvents and synthetic dyes. This failure results in the direct discharge of toxic chromium and carcinogenic azo dyes into the local ecosystem. These chemicals don't just stay in the river. They sink through the soil and poison the groundwater used by downstream communities. The visual evidence of this contamination is undeniable. We see rivers covered in thick blankets of toxic white foam, a chemical reaction so aggressive it actively corrodes the local infrastructure. This heavy metal poisoning is the predictable result of prioritizing industrial growth over the enforcement of basic environmental safety laws. The most advanced threat, however, is already inside our homes. These are PFAS, synthetic chemicals found in waterproof gear and scratched nonstick pans. They are designed to repel water and grease, making them incredibly useful and incredibly dangerous. PFAS are built on the carbon-fluorine bond, the strongest link in organic chemistry. Because nature cannot break this bond, they never degrade. Instead, they bioaccumulate, stacking up in human tissues year after year with every contaminated meal or glass of water. The long-term health effects of this accumulation are profound. PFAS causes suppressed immune systems, severely disrupted hormonal balance, and increased risks of cancer. These molecules are small enough to pass through standard municipal filtration systems undetected, making them a permanent fixture in the modern human body. Most municipal water plants were built to handle sediment and bacteria. They have no physical way to catch a uranium atom or a PFAS molecule, meaning your tap water is likely carrying whatever was dumped upstream. Currently, the only effective defense is point-of-use filtration. Homeowners must rely on multi-stage reverse osmosis or granular activated carbon systems to act as a final barrier before the water is consumed. These filters work by using microscopic pores or porous carbon to physically trap heavy metals and carbon-fluorine chains, letting only the pure water molecules pass through to your glass. But individual filters are just a temporary fix. True safety depends on a massive shift in government enforcement to meet global 2026 water standards, stopping industrial pollution before it ever reaches the aquifer. Until systemic pollution is halted at the source, every drop of tap water requires active defense. Our survival now relies on individual filtration rather than the public systems we used to trust.